Studies Section 6, Correlations. Introduction. The present study section introduces you to some forms of correlational analysis. The correlation analysis discussed and worked in this study section include Pearson R and Spearman rank order correlations. The two correlation analyses discussed in this study section have peculiarities in their use. In other words, data where Pearson correlation is applicable, a Spearman rank order correlation will not be appropriate. Objectives. At the end of this study section, you should be able to 1. Explain and calculate Pearson correlation, and 2. Explain and calculate Spearman rank order correlation. Pretext. What are the differences between Pearson and Spearman rank order correlations? Content. Correlations. Correlation is a statistical tool or technique that is used to know whether there is a relationship or association between two variables, e.g., variables x and y. It is calculated basically to know whether the nature of relationship between two variables is positive, negative, or zero. Positive correlation suggests that as x increases, y also increases, or as x decreases, y also decreases, and this can be referred to as direct relationship. Negative relationship occurs when x increases and y variable decreases, and this is referred to as indirect or inverse relationship between x and y variables. The correlation coefficient of 1.00 indicates a perfect linear relationship between the two variables. Apart from the direction in correlation, there is what is called the degree of the relationship, where the coefficient ranging between 0.60 and 1.00 are strong, those ranging from 0.40 and 0.59 as moderate, while those ranging from 0.01 and 0.39 as weak, respectively. Finally, it is worth noting that in correlation, there is no cause and effect relationship, meaning x variable does not cause y variable, rather they could only be related. Within the scope of this course, you will be limited to Pearson R and Spearman rank order correlation, RHO. The Pearson correlation. The Pearson correlation, which is also called the Pearson product moment correlation, specifically enables the researchers to assess the nature of the relationship between two variables, x and y. Correlations are based in pair of variables, and each pair is based on the responses of one person. In other words, scores on the two variables x and y are gotten from same persons. It is commonly denoted by R, and to calculate the Pearson correlation, there is computational formula for this. The computational formula is shown below. The degree of freedom, VF, is equal to n minus 2. Example 6.1. The following data are given as a set of scores for 10 students who participated in a scale validation study, that is, fraudulent intent and lie scales. Table 6.1, showing scores on fraudulent intent scale and lie scale. X, that's fraudulent, 20, 5, 18, 6, 19, 3, 4, 3, 17, 18. Y, lie scale, 8, 2, 10, 3, 8, 4, 3, 2, 7, 9. First, you need the following to be able to calculate Pearson correlation based on the formula: the sum of x, summation x, the sum of y, summation y, the sum of the product times of x and y, summation xy, the sum of the square of x, summation x squared, and the sum of the square of y, summation y squared, based on the example given. Summation x is equal to 113, summation y is equal to 56, summation xy is equal to 831, summation x squared is equal to 1793, summation y squared is equal to 400, summation x in brackets then squared is equal to 12769, summation y in brackets squared is equal to 3136, and n is equal to 10. Insert these values in the formula, you get r is equal to 0.94 approximately to 2 decimal points. df is equal to n minus 2 is equal to 10 minus 2 is equal to 8. Interpretation. At this stage, consult your statistical table to determine whether the calculated value is significant or not, using a degree of freedom of 8 with critical value at 0.05 level of significance, one-tailed test, which is 0.55. This means that our calculated value 0.94 is greater than the critical value 0.55, suggesting that the H0 is rejected. In other words, there is a positive relationship between fraudulent intent scale and lie scale. R is equal to 0.94. Degree of freedom is equal to 8. P is less than 0.05. This is described in that the higher the fraudulent intent, the higher the tendency to tell lie among the students. However, to determine the degree of the relationship between fraudulent intent and lay scales, there is a need to calculate coefficient of determination, that is denoted by R squared. It explains the variation in one variable that can be accounted for by variation in the other variable. In other words, one can say variable x predicts variable y. When R squared is multiplied by 100, it gives us percentage of the variance in y that is associated with or accounted for by variance in x. Based on our R is equal to 0.94, the coefficient of determination R squared is equal to 0.94 in bracket squared is equal to 0.88. When 0.88 is multiplied by 100, it gives us 88.36% of variance in lie scale that is associated with or accounted for by variance in fraudulent intent scale. The Spearman correlation. Another type of correlation coefficient that is used to determine the nature of association or relationship between two ordinal data is called Spearman rank order correlation coefficient, denoted by rho. When actual values of the variables given are not available, the data may be ranked from 1 to n in order of size, importance, etc. And this statistical technique can be used to determine the coefficient. It is appropriate when the relationship between two variables is not linear, but shows consistency of direction. In other words, small increase in x will lead to dramatic increase in y. Here is the formula for the Spearman rank order correlation. Rho is equal to 1 minus 6 summation d squared over n into bracket n squared minus 1 in bracket, where d is equal to the difference between rank of the values of x and y. N is the number of pairs of value x, y in the data given. Example 6.2. The following is given as the scores of 10 students in a debate. The scores are from lowest to highest as shown below. Example 6.3. Use the following data to calculate the Spearman rank order correlation. The procedure described above can be used for the exam and test scores of 10 PSY 319 distance learning students. The table is shown below and the calculation is also shown below. Rho is equal to 1.00. Interpretation. Check the statistical table to know whether the obtained calculated value is significant or not using the actual n as degree of freedom at 0.05 level of significance, one-tailed test. The critical value is 0.50. Since our calculated value 1.00 is greater than the critical value 0.50, we reject H0 and accept H1. This indicates that there is a significant relationship between the student test and exam scores. Rho is equal to 1.00, P is less than 0.05. Summary: in the study section, correlation analysis were discussed and calculated. Specifically, Pearson and Spearman rank order correlations were explained and calculated with their formula. Examples were given and were calculated with interpretation. This is the end of study section 6. Thanks for listening.